Hello my dear students. This is a short video on the rules to follow in reporting the values with correct number of significant figures when we perform calculations. Watch my previous video on counting significant figures before you watch this one for better understanding. Now please remember that your answer cannot be more accurate than the least accurate measurement. Always remember this. First, let's talk about how to count the correct number of significant figures for multiplication and division, or how to report the answers with correct number of significant figures in multiplication and division. When you're performing multiplication and division, you must report your answer with the same number of significant figures as the least number of significant figures, or as the number with the least number of significant figures. Now let's take that out with some examples. Let's take the first example. 137 times 34. My answer is 4658. Now I need to report this number, the answer, with the correct number of significant figures. 137 has 3 sigfigs, 34 has 2 sigfigs. So my answer should have only 2 sigfigs, because in this calculation the number with least number of significant figures is 34, which has only 2 significant figures. Now I need to do my rounding off. How do I do the rounding? Look at the leftmost number that has to be removed. In this case, the leftmost number that has to be removed is this 5. Now, if the leftmost number that has to be removed is 5 or greater than 5, increase the preceding number by 1. Therefore, the 6 here becomes 7, and my reported value would be 4700, which has 2 sigfigs. Another problem here. 636 times 6.200, which is equal to 3943.2. 636 has 3 sigfigs. 6.200 has 4 sigfigs. Remember, if I have a number with trailing zeros and the number has a decimal point, I count the zeros as significant. Now the answer should have only 3 sigfigs. Why 3 sigfigs? Because the measurement with least number of sigfigs here is 636 with 3 sigfigs. So I need only the first 3 digits in my answer. Now I have to figure out about the rounding off. Now look at the last number that has to be removed. The leftmost number that has to be removed is 3. Is this greater than 5? No. So I keep the number as such, or I keep the 4 as such. So my answer would be 3940, 3940. The next problem is a division. 4.678 divided by 8.93. The answer is a long one, 0.52385218. Should I report this as such? No. 4.678 has 4 sigfigs. 8.93 has 3 sigfigs. So my answer should have only 3 sigfigs. So how do I report it? Do the rounding and give me the correct answer. Yeah, that's right. My answer would be 0.524. Now I need only 3 sigfigs. So I have to keep only the 5, 2 and 3. But I look at the leftmost number that has to be removed, which is 8. 8 is greater than 5. So the last digit 3 gets increased by 1. So it becomes 4. So my answer here is 0.524. Check out the rules for addition and subtraction. For addition and subtraction, your answer cannot contain more decimal points than the least accurate measurement. Here we look for the decimal points. Let's check out our first example in this. Line up the decimal points in the numbers when you have an addition problem. So I have here an addition 3.515 plus 1.7 plus 13. Step 1 is to line up the decimals. 0.25 plus 1.7 plus 13 gives me 18.215. My answer would have only one decimal place because the number with least number of decimal places is 1.7, which has just one decimal place. My answer stops with 18.2. Stops with 18.2. No rounding is necessary. Why? Because the leftmost number that has to be removed is 1, which is less than 5. Let's check out this problem. 3.515 plus 13 divided by 1.7. If a problem has multiplication or division along with addition and subtraction, go by the rules for multiplication and division. Here the answer again is a lengthy one, but I follow the rules for multiplication and division. Here 1.7 is the number with the least number of significant figures. It has only two significant figures. So my answer should also have only two sig figs. My answer would be 9.7.